joining us today. We're going to go over an introduction to the streamside evaluation requirements outlined in the Water Quality Management Plan of the 2025 Willamette Subbasins Temperature TMDL. Joining us today are Willamette Basin Coordinators, myself, Priscilla Wolverton, Grace Goldrick-Middaugh, Andrea Motzke, Brian Krutzberg, and Sarah Matichek. We also have one of our basin specialists, Chance Plunk, presenting today, and our other basin specialist, Valerie Arkell, is also on the line today. Next slide. I want to point out a couple important and upcoming due dates for most of the folks joining this webinar today. Responsible persons, including designated management agencies or DMAs, submit implementation plan updates every 5 years. But in addition to these regularly scheduled updates, everyone has to submit an implementation plan update specific to the new temperature TMDL requirements. And these updates are due by November 9th, 2026. These temperature TMDL specific updates are expected to be pretty minimal. For example, just updating any references to old temperature TMDLs and allocations, and updating the implementation plan to add the timelines and milestones for the new streamside evaluation and the Oregon Watershed Restoration Inventory requirements. If you have any questions about how to edit or add these actions to your implementation plan, please reach out to your basin coordinator. And then the completed streamside evaluation, that's due by May 9th, 2028. And I know 2028 coincides for a lot of DMAs with your next regularly scheduled Year 5 implementation plan update. We're not going to focus on discussing the timing of anyone's specific Year 5 implementation plan updates and how this does or does not line up with the due date of the completed streamside evaluation today. So if you have questions about your next regularly scheduled Year 5 review, its implementation plan updates, and the due dates that you see on this slide, please contact your basin coordinator directly to have that conversation. I also really want to encourage you to reach out to your basin coordinator and discuss the streamside evaluation specifically in terms of your jurisdiction. As you'll see, there are different methods for completing this evaluation, and it would be prudent to talk through them with your basin coordinator to make sure that you're going to meet the minimum requirements of the Water Quality Management Plan. Next slide. All right, so let's get into the streamside evaluation requirements. You can find these requirements outlined in section 5.3.2 of the TMDL Water Quality Management Plan. The streamside evaluation represents an analysis of land and vegetation conditions and characteristics next to rivers and streams. It includes identifying and prioritizing where to protect and plant shade-providing vegetation. This evaluation provides a way for DMAs to link available streamside data to how they are or can implement the temperature TMDL requirements for increasing shade on streams. Next slide. The primary goal of the streamside evaluation is to present a prioritized plan for protecting and restoring shade on rivers and streams. This plan must be supported by a clear rationale or explanation that takes into account all of the information required by the Water Quality Management Plan. And over the next few slides, I'm going to go into detail about what types of information the Water Quality Management Plan requires. Next slide. There are 7 parts to the streamside evaluation. And again, you can find these described in section 532 of the Water Quality Management Plan. The first 4 parts of the evaluation focus on quantifying different streamside conditions and characteristics based on whether an area needs to be enhanced versus maintained and protected, and what types of constraints, physical or jurisdictional, might affect restoration or protection efforts. The goal here is to categorize and quantify the streamside area within your jurisdiction and incorporate this information into your rationale for how and where you're prioritizing implementation of the temperature TMDL. Next slide. So, what are some of the data and methods available to help DMAs categorize and quantify their streamside area according to the categories shown in the Water Quality Management Plan? This slide represents just an overview of the types of data and methods that a DMA could use to delineate and quantify streamside acres that need enhancement versus protection and maintenance, as well as identify physical and jurisdictional constraints. Again, this is just an overview, and we know there are other data and methods that could be used. The data that DEQ can provide are either available to download from our website or can be requested by sending an email to your basin coordinator. Today, we'll be presenting two different methodologies for completing the streamside evaluation, and both use some of the data sources shown on this slide. In terms of methods, Chance will utilize the DEQ interactive map, and Grace will then share a GIS-based approach. Again, DMAs are not limited to these data and the two approaches that we're sharing today. DMAs can definitely propose other data and alternate methods to complete the streamside evaluation. Just please talk to your basin coordinator and let them know what you're thinking. Before we talk more about a couple specific data sources and share a couple methodologies, let's first tackle these questions. Which water bodies need to be included in the streamside evaluation, and what is the streamside area? The water bodies that you need to evaluate include all the mapped water bodies within your jurisdictional boundaries. Your jurisdictional boundaries should include land that's owned or managed by your agency. The streamside area, or the area we might refer to as the riparian area, is the area adjacent to the stream. But what counts as stream adjacent? Well, the Water Quality Management Plan doesn't define a specific buffer width for the streamside area. And the examples we're going to share today will provide some recommendations, but it's up to the DMA to define the buffer width they'll be using to complete their streamside evaluation. But it's got to make sense. A 10-foot buffer is not going to support the type of plant community that's needed to shade most streams. We're expecting buffer widths to be clearly articulated and supported by the data selected and the rationale presented in the streamside evaluation. Again, this is something you will want to talk about one-on-one with your basin coordinator. Next slide. Okay, so let's look at a couple of the DEQ specific data sources you saw mentioned just prior. So DEQ completed a streamside shade analysis using LiDAR data for most of the southern Willamette Basin and portions of the lower Willamette Basin. From this analysis, DEQ calculated shade gaps, which means the difference between current percent shade on the stream and the target effective shade on a stream for a given location. Larger shade gap values mean there is less shade on the stream, and smaller shade gap values mean there's relatively more shade on the stream. In other words, the smaller the shade gap, the closer you are to meeting the TMDL's target effective shade goals. DEQ's interactive map shows the results of this modeling, and these results are organized as model nodes or points that display the shade gap value. The model nodes or shade gap data are shown every 50 to 200 meters apart along a stream, depending on the area of the basin. It varies. The Water Quality Management Plan specifies that if DEQ shade gap results are available in your jurisdiction, then you must address them in your streamside evaluation. What's that mean? It means you need to specifically talk about DEQ's shade gap analysis results for your jurisdiction and how they're being used to inform the prioritization plan of your streamside evaluation. So as you saw on the map on the previous slide, DEQ did not complete a shade gap analysis for the entire Willamette Basin. However, we can provide a data set that we're referring to as the planet data. And this includes modeled canopy height and canopy cover percent based on remotely sensed data from 2022 and 2023. This data set covers the entire state and is in the form of a raster with 10 by 10 meter cells. Canopy cover percent values range from 0% no canopy cover to 100% full canopy cover. Now, this is not the same as percent shade or percent shade gap, but it can provide a proxy for riparian vegetation for the purposes of the streamside evaluation. DEQ can only share these data sets to support implementation of the Clean Water Act. This means the data can be used to help as you develop your implementation plan or complete your streamside evaluation, but it cannot be posted publicly for anyone to access. This is why this data set is not included on our website. If you're interested in using the planet data, again, just reach out directly to your basin coordinator and they'll be able to connect you with that data set for your jurisdiction. The Willamette Subbasins Temperature Replacement TMDL website also includes a link to an interactive map that you can use to view various data layers, including map jurisdictions, water bodies, as well as the shade gap nodes from our shade gap analysis we just talked about. This is a good first stop for seeing if DEQ is able to complete shade gap modeling for your jurisdiction, as well as to view the mapped water bodies that overlay your jurisdiction. Chance is going to share this tool specifically today and give an example of how to use it to help complete a streamside evaluation. And he'll provide that example in just a few minutes. All of the data shared through this interactive map can also be downloaded as a geodatabase and used within ArcGIS software. Thanks. So now, let's look at an example of delineating and categorizing the streamside area. Again, the streamside area itself is just an area adjacent or next to a water body. DEQ used a 150-foot buffer width from the stream center line to define the streamside area for the shade gap model. But as I mentioned before, the water quality management plan does not identify a specific buffer width that must be used in the streamside evaluation. Each DMA will need to provide a rationale for the buffer width they've decided to use. So for example, the buffer width could be aligned with an existing riparian ordinance or the existence of a protected greenway, DLCDs, safe harbor, buffer widths, etc. Whatever the buffer width chosen for this analysis, it needs to be big enough to support a plant community that provides streamside shade at maturity. All right, so in this image, you can see a streamside area that's been delineated using a hypothetical 75-foot buffer from approximately top of bank. Within the 75-foot buffer, we can see there's a highway that crosses the stream, a footpath on the right bank, and trees in some places. We'll look at how to address all of these elements in the streamside evaluation over the next few slides. So here you can see where we've highlighted the 70-foot buffer as either needing enhancement or as needing protection. The area that needs enhancement is lacking shade, providing vegetation, and the area that needs protection is an area that already has a lot of good shade on the stream. It's looking pretty good. It just needs to be maintained and protected moving forward. Next slide. In this slide, we've color-coded the 75-foot buffer according to whether there are any jurisdictional or physical constraints. For example, where there's a highway, there's no opportunity to plant trees. So that represents an area with physical constraints. The area that's in private ownership may present different types of jurisdictional constraints. For example, maybe there's development restrictions within this buffer on private property, but maybe there's no requirement in ordinance or development code to plant or maintain riparian vegetation. And then in this image, we put it all together. We've quantified the streamside area according to categories of areas that need enhancement or protection, and whether there are physical or jurisdictional constraints. Using these categories supports prioritizing implementation as well as tracking progress over time. For example, of the 1 acre that was identified as needing enhancement and has no physical or jurisdictional constraints, how much of this area improved or got worse in terms of streamside vegetation and shade over time. So this is going to help give DEQ a clearer picture of on-the-ground progress or challenges over time. And here are just those same values from the previous slide shown in a table format. I think it's worth mentioning here that tracking these numbers over time is one of, but not the only, piece of information that DEQ will use to assess DMA compliance with the TMDL. DEQ will continue to use implementation plans and annual and year 5 reports to assess implementation compliance. Tracking all of these pieces is especially important for this TMDL because we know that establishing and protecting streamside vegetation to provide stream shade can and will take decades to achieve. So we've gone through just a brief example, a simple example of calculating the values required in the first 4 of the 7 parts of a streamside evaluation. Now we'll look at the remaining 3 elements of the streamside evaluation. So part E of the evaluation is specifically asking about the opportunities that exist to overcome any of the physical or jurisdictional constraints to implementation. For example, if an area needs enhancement, but it's in private ownership, what are some ways to work with private landowners? Maybe the focus is on incentivizing voluntary actions, or maybe efforts to create a more robust riparian protection ordinance are needed. So that's just an example of the types of discussion we want to see in Part E of the evaluation. And then Part F of the streamside evaluation asks DMAs to identify opportunities for implementing strategies that may not be directly related to increasing shade on streams. For example, maybe your jurisdiction is implementing in-stream restoration projects that benefit stream temperature. If that's something that you are doing or plan on doing, we definitely want to see that captured in your evaluation. And then finally, the last element of the evaluation,
Okay, no
Part
problem.
G,
Yeah,
is
I'll
ask
just look through your
DMAs
part time, and then
to.
I'll-
We've got a talker on the line. Please mute your phones. And then the final element of the evaluation asks DMAs to synthesize all of the information from parts A through F and articulate a rationale or explanation that supports how a DMA is going to prioritize and implement the temperature TMDL. So again, section 5.3.2 covers the minimum elements required in a streamside evaluation. But DMAs are also encouraged to consider additional factors that may impact enhancement or restoration or protection efforts. So where possible, DMAs should consider the potential impacts of climate change, including shifting natural hazards, as well as the resiliency of planted species to altered temperature regimes and water availability. Restoration projects should, to the extent practicable, be suited to the projected future range of conditions. So DMA should consult best available data sets to characterize future conditions. More resources on this are linked at the end of this slideshow. But again, this is just an overview and some examples, and there very well may be other sources out there that you would like to include. And if there are, please share them with your basin coordinator. And additionally, when developing priority project types and locations, DMAs are encouraged to involve communities within their jurisdictions that may be disproportionately impacted by historic and current water pollution. DMAs are also encouraged to consider data sets and input from community-based organizations, solicit input from groups that may not be traditionally involved in the public process, and consider creative solutions that can meet both water quality objectives and community needs. Some resources related to equitable implementation are also linked to at the end of this slideshow, but please, if there are others out there, share them with us. Okay, just a quick note here before we stop for a short Q&A. The resources, tools, and methods that Chance and Grace will be sharing today represent only a selection of available approaches and not the universe of options that exist. However, the methods we're sharing today were specifically selected because they're either free to access and use, or they're common techniques already used by most cities and counties. Ultimately, each DMA is responsible for clearly describing their chosen data and methods for completing the stream site evaluation. We're encouraging everyone to reach out to your assigned basin coordinator to talk about available data and potential approaches. I know I've mentioned that a few times already, because I just really want to emphasize how important that is to make sure that your basin coordinator understands the method that you're using and agrees that the approach is going to meet the minimum requirements of the water quality management plan. Next slide. And here we'll go ahead and pause for a few minutes, and I can take any questions that folks have just over this introduction to the stream site evaluation. And if there are none, we can jump right into the examples. All right.
Sounds like no questions, so I'll just jump right into it. Good morning, everyone. Thanks for joining today's training on the stream site evaluation tools. My name is Chance Plunk, and I am a Willamette Basin Specialist with Oregon DEQ. Today, I'll go over how to use this tool and how it supports your organization's water quality management plan responsibilities, and specifically how it helps DMAs document, evaluate, and track stream side management actions that align with the TMDL implementation goals. So this stream site evaluation tool was developed to help small jurisdiction DMAs that may not have an established GIS program, and to help them meet the requirements of Section 5.3.2 of the Water Quality Management Plan. It allows each DMA to identify stream site areas needing enhancement or protection and document management actions. And the ultimate purpose is to strengthen riparian protection track implementation progress, and provide transparent data to support adaptive management. So in order to access the Streamside Evaluation web map, you'll need to contact your basin coordinator to request the Streamside Evaluation web map link. Following your request, we'll send you the link along with a set of step-by-step instructions that detail the process of using the tool. You'll then open the link using a supported browser such as Google Chrome, Microsoft Edge, or Firefox on a desktop or laptop computer. So while the tool was created in ArcGIS Online, there is no sign-in required. So anyone with the link can open the map and begin mapping streamside areas. Do avoid using private or incognito mode, as this may prevent your work from saving correctly. And then once the map is open, take a few minutes to familiarize yourself with the layout and available map layers before creating your first polygon. So navigation is simple. You can pan and zoom around with the map, with your mouse or touchpad, or use the search bar to jump directly to a location or address. You can also toggle reference layers like subbasins or DMA boundaries to help orient your work area. And we recommend, again, that you spend a little time exploring before you start drawing to make sure you're centered on your target stream segment. Once you're ready to start your evaluation, you'll expand the sidebar and then click the Edit button in the toolbar. You will then select New Feature, and that will open the Polygon Drawing tool. So once zoomed in to the appropriate area and ready to draw your polygon, you'll click on the map to place your first point. Then continue clicking along the boundary of the area to outline where you want to evaluate. So try to follow the riparian zone as accurately as possible. And if you make a mistake while drawing, you can press Ctrl-Z to undo the last point. When you're finished drawing your polygon, you'll double-click to close that shape. As soon as you finish drawing, the polygon will close automatically and the data entry form will appear on the right side of the screen. So after you've drawn your area, you'll complete a short form. Two of the fields, subbasin and acres, will fill automatically based on the polygon's location and the size. The remaining fields of DMA is a drop-down menu, categorization, enhancement, or protection, type of constraints for jurisdictional, physical, or both, BMP opportunities, yes or no, and priority rank, high, medium, or low, are all require your input. These fields will help DEQ and DMAs identify where work is needed most and what kind of barriers exist. So this table provides a quick summary of how to complete each of the 4 streamside evaluation fields. So the first field is BMP opportunities. Here, DMAs identify where feasible enhancement or protection actions can occur along a stream reach. You'll want to review the riparian condition, land ownership, and any site feasibility factors. And if the reach has room or need for improvements, such as planting native vegetation, removing invasives, or adding livestock exclusion fencing, mark yes for BMP opportunities. If the reach already meets the target conditions or there's no realistic opportunity due to infrastructure or other constraints, you'd mark no. Next is categorization. Each reach should be classified as either enhancement or protection. Choose enhancement when the site does not meet shade targets or needs active restoration. Choose protection when the site already meets target riparian conditions and the goal is to maintain them in short. Enhancement means improvement is needed, and protection means keep it functioning as it is. The third field is priority rank. DMAs will assign a high, medium, or low rank based on overall benefit, feasibility, and any constraints identified. High priority sites are where restoration will provide the most shade benefit or where willing landowners and partnerships make implementation achievable. Medium priority sites offer moderate potential or face some implementation challenges. Low priority sites either already have limited opportunity for improvement or face significant barriers that make short-term action unlikely. Remember, the Water Quality Management Plan emphasizes that DMAs should include the rationale for why each site is ranked as it is. And then finally, the type of constraints field documents what might limit implementation. These are the physical or jurisdictional limitations described in section 5.3.2. Physical constraints include things like roads, buildings, or other permanent structures that prevent repair and restoration. And then jurisdictional constraints apply where the DMA doesn't have authority or access, such as private property or lands managed by another entity. If both types of barriers apply, mark both. If there are no known barriers, you would mark none. Completing these 4 fields thoroughly and consistently provides DEQ and DMAs with a clear, defensible picture of where streamside improvements can occur and how to prioritize them within each watershed. So when your form is complete, you'll click Create or Save. So your polygon is automatically stored in the hosted feature layer, meaning it's part of the shared data set now. So after saving, you can click your polygon to view its pop-up with all the details you entered. If you don't immediately see it, try refreshing or zooming slightly and it should reappear. And of course, always review your saved entries for accuracy before moving on. After you have entered multiple polygons, you can query the polygons that are specific to you and your organization. You'll first select the filter option in the tool menu on the right side of the screen. You'll then select Add New. 3 drop-down boxes will appear. The top one will select Designated Management Agency. The middle drop-down you will select Is. And the bottom drop-down you select the DMA you represent. This will highlight only the polygons that your organization has entered. In order to see all of the entries by your organization, select the pop-ups option in the panel on the right side of your screen. A pop-up window will appear. You will then select the table option from the menu that appears in the pop-up window. This will open a table. You will then select the Show All option on the left side of the pop-up window. That table will now include all the entries from your organization selected in the filter. You are then able to select an entry in the table and zoom directly to that location or scroll the table to see all of your entries. Here are a few tips to make your workflow smooth. So you'll draw carefully along the stream corridor for best accuracy. Double click to finish each shape. If you make a mistake, use Control-Z to undo the last point. And finally, be sure that all required fields marked with an asterisk are filled. The system will not let you save unless all required fields are completed. Following these steps will ensure consistent, usable data for your stream-side evaluation. If you have any questions or run into technical issues, please reach out directly. You can contact me directly via the provided email or phone number on this slide. I will now run through the same steps with a live run-through of how to use the tool. Give me a second, let me get transitioned here. Okay, so once I send you the link, you will select the link and that link will bring you to this page here. When you get to this point, you will select Open in Map Viewer. Again, making sure that you're either in Google Chrome or Microsoft Edge or Firefox. Okay, so once the map loads, this is what it should look like. Just to kind of orient you with everything, over on the left side, we have our layers. This is all the different layers that you have for your availability to do your analysis. We included the heat source nodes. Just as a disclaimer, these will be renamed at a later date before you get sent the links when you request them. And these will be easier to understand and be able to tell clearly what each one is. But as we go down the list, So we have our main layer, and this is where we're going to be drawing our polygons. This is for our actual streamside evaluation. And then we have our heat source shade nodes. So you can tell where areas have higher impacts from temperature. Red is bad, blue is better. So you can use that to help determine where to do your restoration. We also have the AU water bodies available, the NHD flow lines, as well as land ownership and jurisdiction. So you can verify that you're in an area that you manage. And then the HUC-8 boundaries. Okay, so from there, you have two arrows on the bottom left here and on the bottom right over here. These will expand your side toolbars. Okay, so as we start, you will want to select on the main layer, the Streamside Evaluation tool itself. From here, you will select the Edit button. And now that we have the edit selected and we are ready to make our choice. So I'm going to turn on the heat source node so we can kind of determine where we're at. I've already zoomed in this map. I'm in the Albany area, but if you wanted to search, you could easily click the search bar here. And let's just say we're in Albany. So then we select, and it'll zoom us directly to our location. Okay. So once you have arrived to your location, okay, you're going to select new feature, and we are now ready to draw. So I'm going to use the heat nodes as I zoom in. Sorry, let me back up a second. Okay. I just want to be able to zoom in first. So we're going to zoom in here, and you can see on the stretch of river here, you can see these areas that have shade issues or higher temperature issues. And you can also look at the legend right here, and that includes your heat source. Whatever layers you have open will be available here to see. So you can use this for your legend. The higher the number, the more enhancement is needed. The lower the number, more protection is needed. So again, so we're going to zoom in here. So we have this stretch right here where we can see that there's some shade issues. So I'll select the new feature. So now as I'm ready to draw, now we'll come in and we'll put our first point. Once you click that first point, then you'll have these lines that just kind of move around. There will also be a buffer tool added onto this map when it gets sent out. It is still in the process of being developed. So as you draw, you just click each point that you're making as you go along. And then as I was saying earlier, if for some reason you mess up and accidentally click somewhere and then your shape's looking weird, then you can press Control Z and it removes that last point and puts you back where you were. So then we can go in, we can finish drawing along our stream. And then this will be the last point. So at this point, we will double click. Okay, so now our shape has closed and we have our first polygon. So as you click the final polygon, your form that you'll need to fill out will pop up right here on the right side. And as I stated earlier, sub-basin and your acres will automatically calculate for you. So those won't need to be done. As for designated management agency, you just click the drop down and a list of all DMAs are in the list. So you just go find who you are. And today, let's just say that we are Albany since we're in that area. Okay, and then acres is already calculated. So then categorization. So we open this up and we can do enhancement or protection. Since there is a higher issue, we're looking in the 26 to 50 range. This would be an enhancement. And then we're going to look at types of constraints. Okay, so we have an agriculture field here. So let's just let's say that this is private property and we might not have access. So potential constraint, let's call it jurisdictional. And then we'll go into BMP opportunities. And do we have opportunities for BMPs, yes or no? So let's just say yes. Okay, and then finally we'll do our priority rank. So this is where the culmination of everything. So we have access, there is an area that needs enhancement, there may be some jurisdictional constraints. So with our priority rank, since we may have those jurisdictional constraints, I'm going to call this one a medium priority, as opposed to somewhere that we know we can get on and access and we have the funding and everything we need for that process. Okay, so once everything is filled out, everything is required to be filled out before you can click save. And we'll click create. Okay, so now that has saved our map, or saved your first polygon. And then at this point, you can now zoom out, or you can come to the other side. And we start drawing again. And I'm just going to do this quickly for sake of the demo. We'll double click. So now we have our other side of the stream. We'll do the same things. Call this Albany. Acres is already calculated for you. Categorization. We're going to call this side protection, since it already has all the trees and lots of vegetation established, and the focus is more to the other side where there's less of that protection. Types of constraints. On this side, let's say no constraints. And then BMP opportunities, we'll say no. So priority rank on any sort of restoration in this area is low. It's more focused on protection. So now we'll hit create. Okay, so now I have a couple polygons entered. So now we have finished entering all your sites at this point, and we decide we want to go back in and we want to see what all you have selected. So you go back into the map, it's a later date, so we're way out here and you can't see where your polygons are at, okay? So what you can do, so you can query your own individual results. When you come back into the map, you can hit filter. And then we'll hit add new. And we're going to keep the condition, and we're going to change the condition to designated management agency. And then we'll select the middle as is. And since those last two were Albany, we'll say we're Albany again. And save. Now, at this point, you hit pop-ups. And this little pop-up will come up. So now this is only showing one, so we can hit table. And it only has the one selection, so I'm going to uncheck that. And then we're going to select the three dots, and you select show all. So now we have all the listed entries from Albany. And you can scroll left or right if you wanted to see these individually, and you can document these ways. Unfortunately, without signing in to ArcGIS Online, we are not able for you to be able to download directly from here, but I do have a workaround for that as well for you. So from here, you've got all your entries in and you're happy with how everything looks. So I will have a second link that will be sent to you. And when you select it, it will take you to this page, and it is the Streamside Evaluation Data Viewer. At this point, you'll just click View. Waiting on this to load. Okay, so once this comes up, everything is going to come in from all the entries. So here you'll just click the three dots, and then you can export to CSV. And at that point, once you get the CSV, which comes out looking like an Excel file, at that point, you can query each row and you can break it down to where it's just your organization and your entries. And again, just kind of a follow-up on some helpful tips. Just making sure you draw carefully, double-clicking to close those shapes. If you make a mistake, again, using Control-Z to go back, making sure all your required fields are filled out. And then, again, for any sort of technical issues or questions, feel free to contact me directly. And I would now be happy to take any sort of questions if anyone has any.
Awesome,
Questions,
thanks.
comments, or concerns.
Thanks, Chance. That was really great. We've got a bunch of questions in the chat that I'll start going through. Question number one, and I think Priscilla or Chance could answer this. What is the definition of shade? Both trees and small shrubs give shade. Thank you.
Shade by any other name is shade, right? Shade is shade. We're just talking about shade on the stream. In the water quality management plan and our priority strategies, we specifically call out hardwood and conifer trees, as being priority for getting in the ground to provide shade. On smaller streams, though, you may be able to achieve good shade cover with other types of or a different type of plant community, like large shrubs. So, we're not looking at the types of plants that you're planting from a compliance standpoint, but we are encouraging, plant community that at maturity, will provide good shade on the stream.
Thank you. Chance, I think this will be one for you. Is there a user's guide that is easily available when we send out this application?
Yes. So when you request the link to the specific tool, I'll send you the link to the tool, a link to the data viewer, and provide a copy of the typed out full-on directions, step by step.
Wonderful. All right, the next question we have, the dates listed for many, maybe all, of the heat source shade model nodes are from 2014. Is this accurate, or have they been updated in the last 10 years?
That is accurate. That is accurate, yes.
All right, for the next question, could priority also be based on the value of the vegetation location? For example, the north side less useful for shade than the south side?
Yes, stream orientation is definitely something that you might want to consider when prioritizing implementation, especially if you're looking at planting projects. Mm-hmm.
Yeah. Wonderful. For the next question, would you be able to add the ACOE Willamette revetments as a layer so you know where we have jurisdictional constraints on many of the east side major tribs?
I would need that data layer to be able to add it, but I'm not positive if that would work forever or be relevant to everyone. I'm not sure. Do we have any other thoughts on revetments?
I need to look at that and get back to you, Rebecca. Yeah, let us take a look at that after the webinar, and we'll connect with you directly.
Great. All right, and I think this is for you, Chance. What if you are really trying to stick to a specific buffer width when drawing the polygon? Is there a way to do that?
So when you receive this link, there will be buffers added in. So for the smaller streams, so your first through fourth order, it'll be an 80-foot from center line, and then for your 5th and up and greater than orders, it will be 105 feet buffers that will be on there automatically. And then that should help kind of guide your drawings of where to stay in.
Great. That is all the questions that we have in the chat for now. I think we've got one more presentation and then we'll have another Q&A at the end. So feel free to keep putting questions in the chat and we'll get to them after the next presentation.
All right, my turn. Let me get the slides up again. And hello everyone, I'm Grace Goldrich-Middle. I am the Middle Willamette Basin Coordinator, and I'm going to present a simple GIS approach for completing the streamside evaluation today. It's going to look pretty similar to some of the examples that Priscilla and Chance just talked through, but it will rely on working with staff who have some knowledge of and access to either the ArcGIS software platform or a similar spatial data analysis tool like QGIS. Additionally, the methods and examples that I'll describe today are based on some limited data sets and estimated values that might differ from real-world conditions. And so this example is showing what a streamside evaluation might look like for a relatively small DMA. And some DMAs will have greater access to digital data sets and analytical techniques and might complete more comprehensive streamside evaluations. So now I'll talk about some relevant data sets again. I know we've already covered some of these a couple of times, but DEQ published a geodatabase that we keep referencing, which is on our website that Priscilla showed earlier. It includes our jurisdictional boundaries, the NHD water bodies, and the TMDL shade gap analysis results. And to complete the streamside evaluation, the data sets can be augmented by local or county level spatial data sets, like the location of major infrastructure, the extent of riparian protection or other ordinances, and data that reflects the current conditions of vegetation along streams. So this could be the shade gap nodes, or it could be the planet data that we've discussed, or other satellite imagery. DMAs could also choose to look at data sets that help them further assess their restoration priorities. And some examples of other data sets that could be helpful, if they're available, would be the steepness of slopes near streams, soil types, the location of major water rights, and the extent of the floodplain for your area. So first, to utilize a GIS approach, a DMA would compile all of their selected data layers. A good first step would be to look at your jurisdictional boundaries. So for example, what water bodies are within your urban growth boundary? And are there other lands beyond that that you own or maintain? Are some roads or properties within your jurisdiction maintained by a different entity, like a state park or a county road? And next, existing riparian protections can be mapped. So this might include a data set that shows the boundaries of protected areas, riparian protection ordinances, or other regulatory zones that limit the removal of vegetation. And I'll note that riparian protection ordinances are often measured from the top of the bank, but it's not always easy to access spatial data sets that show the location of the stream bank. And so in the image on this slide, I'm showing the extent of a riparian protection ordinance that was estimated by applying a 90-foot buffer to the mapped center line of Butte Creek to illustrate what a 50-foot from the top of the bank buffer might look like. Other major infrastructure, like the locations of dams, roads, and bridges, can be marked in GIS. And mandated buffers that exist to protect this infrastructure can be estimated as areas where there are physical constraints and riparian restoration efforts will be limited or won't be implemented. And then as a final step, jurisdictional boundaries can be included. So highlight any public properties that are adjacent to water bodies that may be easier to implement riparian restoration projects on. And then in contrast, highlight the locations of private properties where there might be greater limitations on restoration efforts. And a key component of the streamside evaluation is looking at riparian vegetation conditions at a high level. So here I'm going to show an example using the planet canopy cover data from 2023. And in this image, I summarized the canopy cover percent into broad buckets with associated color codes. And here I defined low canopy cover, or area needing restoration, as anything between 0 to 40% cover. And high canopy cover, or areas that have vegetation that might provide shade, is somewhat generously defined here as 40 to 100% canopy cover. And I just selected these really broad buckets by looking at the distribution of canopy cover values within a jurisdiction and roughly breaking the range into 0 to 50th percentile and 50 to 100th percentile. I show 4 different colors on the map to broadly illustrate the variations in canopy cover, but it could be useful as you're completing your streamside evaluations to use more categories or a continuous color scale so that you can see this information in more detail to qualitatively prioritize some areas for restoration. And I'll note we didn't include specific thresholds for canopy cover in the TMDL documents, so you'll need to make your own determinations about what vegetation conditions should be prioritized for restoration versus protection, and articulate that rationale in your streamside evaluation. And then just briefly in terms of the GIS approach, when you're utilizing the planet data in GIS, you can extract the planet raster cells corresponding first to a buffer of the water bodies within your jurisdiction, and then look at the canopy cover values that correspond to each of the categories we require for the streamside evaluation. So for example, what are the vegetation conditions in areas that are near roads or on private properties? And I'll show an example of what this summary might look like in more detail in a couple of slides. But first, some DMAs will also be using DEQ's shade gap analysis results to support their streamside evaluations. And we've already mentioned this, but DMAs that have jurisdictions where the shade gap model results are available must account for the results in their streamside evaluations. And DMAs can take different approaches to incorporate the results into their evaluation. First, remember that in contrast with the planet canopy covered data, a higher value for shade gap percent means that restoration is needed, while a low shade gap means that current conditions are close to the target shade and actions beyond protection might not be needed. One option to incorporate the shade gap model nodes would be to just look at the nodes on a map and compare the values to data sets like the planet data or a satellite image. And you could choose to qualitatively assess those node values. I would ask, can you use this information to help target areas that have high modeled shade gaps and an apparent absence of vegetation? Or do you have some high shade gaps that align with areas you know within your jurisdiction have ongoing issues with the lack of vegetation? DMAs could also choose to base their evaluation on the shade gap nodes by summarizing the node values across an area. And one approach to complete this summary would be to apply a spatial interpolation technique, such as Thesin polygons, to summarize the shade gap values over a stream reach and within a set buffer width from the water body. In the stream reaches that I've drawn on this slide, each polygon contains the area closer to the central shade gap model node than any other node along the stream, and it assigns the shade gap value associated with that node to the area inside the polygon. Let me get my laser pointer. So for example, we could say that this stream reach has 0.2 acres that have a 75% shade gap, while this stream reach has maybe 0.3 acres that have a 40% shade gap. And then similar to what I described for the planet data, I want to get rid of this laser pointer. You would then consider the shade gap values in the context of jurisdictional and physical constraints to riparian restoration and highlight your priority areas based on your evaluation. Whether you're using the planet data or shade gap model nodes, the final step is to summarize these areas like I've been mentioning. And so in the example on this slide, areas to the north of Mill Creek already have relatively high percent canopy cover and should be prioritized for protection. And these areas in red that are adjacent to Turner Elementary School could be prioritized for restoration as there's low percent canopy cover, and this could be a good education and outreach opportunity in addition to a location to improve shade along the creek. Here we have a road and the bridge that's carrying Marion Road across Mill Creek. This would be an example of an area that has low canopy cover, but would be a low priority for restoration because there's existing infrastructure there with buffer requirements to protect that infrastructure. And then finally, here's an example of an area that has low existing vegetation and shade, but it falls on private land. And so this could be an example of an area that would be an opportunity for targeted outreach to encourage voluntary restoration efforts. And to complete a streamside evaluation, a DMA would calculate the areas in each condition and then present priorities for different implementation projects like I've just described for some of these example areas, but incorporating their entire jurisdiction. I want to note that we recognize that for many DMAs, much of the riparian area needing restoration might fall on land that has jurisdictional or physical constraints that preclude implementation of riparian restoration. And so the streamside evaluation is an opportunity for you to present the presence of an extent of these impediments within your area, and then highlight locations where there's opportunities to implement riparian restoration or to conduct other targeted efforts that might improve water quality. I'll also note that I've written an example evaluation and report using the City of Scotts Mills that your basin coordinator can share with you if you'd like to see what a full rationale for categorizing streamside areas and prioritizing restoration actions looks like for a small DMA and using some of the data sets I've shown on the slides. And then finally, thanks for your time and attention today. This table shows all of our contact information for our basin coordinators. If you're not sure which basin coordinator is assigned to you, you can just reach out to any of us and we can get you in contact with the right person. We'll end with some more time now for questions and answers. I'll stop sharing so I can see you all.
Yeah, thank you, Grace. Yeah, does anybody have a question? You can put it in the chat or feel free to raise your hand. Yeah, go ahead, Marcos.
Thank you. When doing this evaluation, if we don't have information on the private property, we say targeted outreach, but how do we evaluate that space prior? Like if we need time, I guess since it's due in what, 2028, we have time to figure it out, but yeah, how do we rank that as medium or high priority, even if the relationship with the private property owner is unknown? How should we be ranking those sites?
Thanks for the question. I can start, and then if others want to jump in, they're welcome to, because I think It depends a little bit on what other opportunities you have to implement restoration. So if you have public properties, those make a lot of sense as a high priority because it'll be much easier to go in and directly plant trees. But there probably will be a lot of cities, especially who most of their riparian area is on private land. And you may not have an existing relationship with that landowner, but you could still conduct outreach to landowners, especially in areas where you've identified low low vegetation or low shade. That could be through mailings using county level data sets, or it could be through other education and outreach opportunities that you have locally. Others may have more to add.
Yeah, I think we'll move. Oh yeah, go ahead. Go ahead, Marcos.
I was just trying to wait to see if anybody else had anything to add, but as far as the ranking goes, it's not as much of an important measurement than it is the actual quality of shade gap. Because back when Chance was talking, he was talking about high, medium, low, and then we have the percent canopy cover. But just like I guess I'm not putting this across very well, but does the high, medium, low, how important is that versus, just actually measuring the shade gap?
So there's kind of two major items for consideration. One is the vegetation condition and one is the constraints. And so having private property would be one example of a jurisdictional constraint that might come up. That's unrelated to the riparian vegetation condition. You could either have private property with a lot of vegetation or private property that's lacking vegetation. And you're going to have to look at all of the different areas within your jurisdiction and what condition they're in, what constraints there are, and think about what you might want to use to assess your specific priorities and rankings of high, medium, or low. Does that make sense?
I think so. Yeah, I'm one of those cities that has a lot of high priority sites in the private area, and so I'm basically trying to figure out whether I can change those priorities because they're not really the outreach isn't as effective as I had hoped, and there's too much constraint for those locations. Thank you.
Yeah, thank you. We're going to go to a question in the chat real fast, and then we'll go to you, Lara. Is it safe to assume all DMAs required to conduct streamside evaluations are listed in Appendix B of the Water Quality Management Plan? Acres of jurisdiction by HUC within 150 feet of stream center line for each entity.
A better appendix to look at would be Appendix A. And in Appendix A, you see the DMAs listed, and one of the columns in that table of DMAs says something like implementation required or implementation needed, something like that. And for any DMA where we said yes, an implementation plan is required, those DMAs are also required to do a stream site evaluation.
Thank you for that.
Yeah, so if the question is who needs to do a stream site evaluation, look at Appendix A and see who needs to do an implementation plan. And by proxy, that would answer that question.
And so if your entity then says in Appendix B not assessed for streamside acres, how do you determine what you're assessing? It's just your ownership?
Right. It would be we may not have assessed it, but you still exist in real life and you have, management authority over some area of stream, of streamside land. So if you're using DEQ's interactive map, you would be drawing those polygons based on your knowledge. And if you're able to use a GIS application, then potentially you could upload your own jurisdictional map that you have. And that's something your basin coordinator could help you figure out, like best method to use based on the data DEQ or your jurisdiction has available.
Okay, thanks.
And that is something that can be discussed with your basin coordinator. I know there are some areas where DEQ may have, said some area of land is owned and operated by a city when really it's maybe a different jurisdiction. And so that's something that can be discussed with the basin coordinator for those specific instances. I think, Laura, did you have a question?
Yeah, just in relation